Hi, everyone. I'm Zack Kass, Global AI Advisor and former head of go-to-market at OpenAI. And today I'm so excited to be hanging out with Vamsi Boppana, the SVP of AI at AMD. Vamsi, it's great to be here.
Thank you, Zach. It's a huge pleasure to be here, and I'm looking forward to chatting with you.
Likewise. And of course, somehow in a fun twist of fate, I find myself today in India, of all places, where you did your studies and you're back home. But thanks in large part to technology, we're able to communicate at a rapid pace in real time. What we need to plan to cover today, at the very least, is hardware architecture, acceleration in open source and frontier in AI innovation, and of course, the big one, which is what's next for developers. And I can tell you now, having sort of stared at this for the last 3 years, it's never been more exciting for developers, but you know this better than anyone.
Yeah, no, it's a great set of topics. It's an amazing time for AI, right? Literally as we sit here, the future of computing is being reshaped. It's an exciting time for hardware developers. It's been said that it's like the golden age of computer architecture by Hennessy and Patterson. But also for developers, right? You are fundamentally getting access to compute that you've never seen in your lives, right? So super exciting.
There are a lot of things that cross your plate every day, and the things that you have to now consider come so fast and furious that I can't possibly imagine how you keep up with all of it. But let's start with the basics, which is, can you just talk to us right now about where compute, first of all, where is compute today? How do you describe where it is today? And then I'll ask the harder question, which is, where is this going?
Yeah. Look, I grew up, as you said, like in India, right? I went to school at the IIT, did computer science, studied architecture, and I got a PhD in computer engineering. And so I feel like I have seen the evolution of compute at least through my career, and for call it, I don't know, 5, 6, 7 decades, right? We have done compute in a certain way. It's the traditional von Neumann architectures, right? And you fetch something from memory, you process it, you write it back into memory, and it's been that style and form of computing. And of course, right, we've had phenomenal gains over all this period. Architecture, but also technology, right? We've really had the amazing ride on the technology curve. In my own career, we have gone from, I don't know, 0.35 micron to now we are like doing 2 nanometers, right? So I don't know how many ever sort of orders of magnitude that is.
Yeah,
it's
many.
Incredible. Many orders of magnitude of improvement. And, Fmaxes went from, I've seen chips at 10, 20, 30 megahertz to, we went to hundreds of megahertz to gigahertz. And, at some point,
and critically, we brought the cost down on all of that too, right? I mean,
that's right.
That's the other remarkable thing that's going on.
It's just amazing, the things that have happened. But as much progress as we have made, you could argue that there is a fundamentally different way of doing compute that we have found and are now starting to think about very, very differently. In my mind, right, in my humble opinion, it's rooted in a few things. The first is, the world is insanely parallel, right? If you think about like when you process an image, right, you're not reading a pixel at a time. You're actually, looking at an image and processing all of that information in parallel, right? You have all these capabilities biologically in nature that allows you to process things in parallel.
Well, some of us, I admit, I struggle to even context switch between simple tasks. But yes, your point is well taken.
That's right. No, you're being incredibly humble, Zach. But yeah, the world is insanely parallel, and there have been various computer architecture innovations that have created parallel machines, and we are seeing those kinds of innovations really, really come to fruition in this time. It's also true that you don't need to process things exactly. There's a lot of room for inexact or imprecise processing. For example, you don't need 64 bits to process, lots of data. You can do just well with 4 bits or 8 bits or even lower. So if you combine all of that, you have a very, very different way of thinking about compute, where you can take in a lot of parallel information, process all of that, simultaneously in an imprecise fashion, and actually get useful work done. And what we are seeing with neural processing and some of the innovations that have come through with compute associated with neural processing is really, really fundamentally shifting how you can do things, right? Algorithms that were traditionally written in ways where you were bottlenecked are completely possible now, because you're able to reimagine them, doing it in parallel, doing it in less precision, and doing it completely differently with neural processing, getting orders of magnitude of gains.
Something that just occurred to me, which was a conversation that I'd had a few times at OpenAI, which is this the chicken or the egg conversation around the algorithms and the software that's driving the evolution of the hardware, or is it the hardware that's actually driving the evolution of the software? And what's your right now? There's this incredible scientific convergence, right, where everything seems to be getting rapidly better. But what's your take here?
Yeah, I think I view that in the general category of co-design. We've always talked about co-design, right? For as long as I've done chips and architectures before, we've always done co-design. What's the workload? What's the architecture, and what's the implementation, right? So that's been central. But now, today, more than ever, co-design is so important. I'll give you one or two ways why it is so, right? To think about it differently. If you did not change your fundamental data type, right? Then you can think of co-design as like, hey, how much prefetch do I need? Do I detect branches in a certain way, right? Model the workload, and you're getting, 5% more, IPC or throughput through your machine, right? And that's important, super important. But can you imagine where, okay, I have a choice now whether I can implement this thing in 6 bits or 4 bits or 8 bits, and what does the machine look like? You could suddenly now have the choices have implications that are factors different, right? Not percentages different. And when you have such big differences, it's so important to really co-optimize and co-design the algorithm, workload, and the machine together.
Speaking of choices, let's talk about one of the things that you and I spoke about recently, the criticality of choices, especially for software developers, and the front and center question now, which is open source versus closed source. And I think, spoiler alert, I think you and I agree on where the world is going and should go. But let's talk about that. What is the future of AMD and open source look like?
Yeah, we are extremely passionate about our commitments towards openness, and open source, building open ecosystems, and it actually permeates through everything we do, from having open choices and enabling open ecosystems on the hardware side, to open choices and software openness through our open source and ecosystem efforts, but also just in how we interact with our customers, right? We are a company that really passionate about delivering exceptional customer service, and being open enables us in unique ways. Let me give you maybe one or two examples. On the hardware and the platform side, right? Can you imagine going to a customer and the customer is being told that you've got to use this exact network choice when they really want something else? There are customers that absolutely love the fact that we would go to them and say, like with AMD, we have an open architecture. You're able to plug in your choice of networking. If you look at software again, right, everything that we do, from libraries to our ecosystem components that interface with frameworks, for example, they're all out in the open. And it's a choice that customers then now have to be able to innovate on top of the open component that we provide. And then if you look at how it manifests, for example, in customer interactions, is many times we actually work together with customers on open repositories where we collaborate in the open, where customer innovation, AMD-driven innovation, and ecosystem innovation are all coming together to fuel innovation at an extraordinary pace that is not possible if it was just being developed in silos.
There are a lot of straw men, and there are some okay steel men that support the closed source and the closed architecture environments. Of the arguments that you hear, what do you think? What do you think are the strongest, and what do you think are sort of the most misplaced?
So look, I think there's always a place in the stack, call it, right, where you may have the need to be closed, right? There could be significant proprietary innovation. There could be requirements from an applications perspective, let's say security, that prevent you to from disclosing certain things into the open. So those are areas that obviously we care for as well, and we make those choices. But anything above those considerations, we tend to lean quite heavily into the open.
I would agree. I think what's fascinating to me right now is whether or not you can make an argument that any given company needs open source. The fact is, the world needs open source in order to move the science forward, and that building in the open, I think we can now sort of confidently say, is one of the great ways that we deliver better, faster, cheaper goods and services to more people at lower costs.
Yeah,
And this is one of these incredible truths that's starting to play out in real time, and is evidenced sort of in part by things like we've seen in from DeepSeek and Meta and others who are moving not just behind, but actually at the state of the art.
that's correct. And that's fueling a tremendous amount of innovation alongside, right? If you look at Llama, you don't think of Llama as just like, hey, here is an open source model, right? You think of a whole ecosystem that rides on top of that, whether it's, frameworks that support Llama, whether it's optimizations, and, whether it's even like, hardware silicon providers that now are able to look at these models and create the next wave of hardware innovation that works well for these models.
Let's talk about the open source frontier and AMD. What are you seeing, and what are you encouraging from your team? What are you encouraging from your partners, and sort of what do you think is in the near term for the open source frontier?
Yeah, as I said, AMD thinks of open development, open ecosystems, and open source fairly expansively, right? We look at it, from a hardware perspective, from a software perspective, and also, in terms of how we think of open interactions with our customers. On the hardware and the platform side, one of the areas that we have been driving a significant amount of open innovation is in the networking space, with respect to the standards that we want the industry to adopt. We are donating things out of internal development into the open, but also then looking for the industry to partner with us. We are collaborating with the industry on things like rack standards, things like data types that we want the industry to collaborate with us on. So there's a number of vectors on the hardware and the platform side, and then on the software side, which is where I think, quite frankly, a lot of our development has been focused on, and a lot of my personal passion also lies is we have been tremendously supportive of significant initiatives that have helped the AI developers. Like we really strongly support the PyTorch ecosystem with CIs that we support, with development that we support around that ecosystem, but also other frameworks like JAX, for example. We support model hubs like Hugging Face that we collaborate with. Also inference frameworks like VLLM, SGLang. We have very, very close collaborations with these emerging open source communities that are thriving in the space. So a number of these initiatives is what I would point to.
So, given that we're seeing improvements in the software, the hardware, the research itself, and given that even you and I couldn't, we could spend all day, every day trying to keep up, but we wouldn't with everything. Maybe you can, but I couldn't. What's your advice to developers for keeping up with the pace? For those who are trying to build, in the open ecosystem, what do you have to say to them?
Yeah, look, again, I think at the highest level, I feel like it's such an exciting time for developers, right? There's just so much more that can be possible with today's compute. I'll give you an example, right? Many years back, right, as I was playing around with the first neural networks, it was, I think, a simple convolutional model that I was trying to train, and it was not easy for me to actually, create my own sort of backbone and train a network, right? Because where could I go, right? Where could I go to get the compute? But now, if you were faced with a similar situation, a developer that wants to do something and kind of build a model architecture that you would want to try out, you have so much compute that actually allows you to do this. Think about even in the last 7-8 years, how much improvement has happened in the amount of compute, right? It's orders of magnitude more compute that developers have access to. So it's an exciting time, right? You can experiment, you can unleash innovation, you can do that. I would also say fundamentally, right, developers can think about their work differently. In the past, it used to be like mastering a tool and mastering some things, that may be, limited in certain ways. But now it's like you have a whole ecosystem to collaborate with, right? You can say, hey, I want to put together a project, and you can say, okay, I'll take various pieces of stack that are readily available in the open community, right? I can take, if it was on AMD, for example, I'll take ROCm. It's all in the open. I'll take an inference library like VLLM. It's all in the open. I'll take a set of models like Llama. That's all in the open. And then you can stitch all of this together very, very, very quickly. Like you can pick one of our Dockers that ships every 2 weeks, and you can be up and running, serving an LLM in literally minutes, right? If not hours. And you can do that on a cloud with public access to extremely capable compute instances. So it's taking advantage of the ecosystem and really being sort of agile, understanding where the ecosystem is moving is one piece of it. The other one that I also am personally very, very excited by is I think it's going to be an age where AI will assist developers significantly, right? If you look at the fresh college graduates that are coding these days, all have assistants sitting by their side, right? Even as they type, the next set of code is getting generated. But sometimes it's actually,
And not just the new software. I mean, the reports are that lots of very seasoned software engineers are starting to adopt these tools as well.
that's right. That's right. And we see that internally, right? We have projects that are coding assistants and, able to solve sort of deep problems. So it frees up developers from quote unquote some of the more mundane, and then it allows you to really focus yourself on creativity, right? I actually can recall a super interesting conversation I had with a professor at Stanford. He runs a venture fund. He has 30 companies in his portfolio. When somebody comes and pitches an idea to him these days, he would tell them that, hey, don't pitch just one idea, pitch 6 ideas, right? And why? Because you can actually prototype all of these relatively quickly. One of these can actually make it, right? So why are you limiting yourself?
What's your take on GPU and CPU? Is there, and you and I have talked about this, but my sense has always been that there's a reasonable chance that actually we're discounting or underestimating how much role the CPU could play in this, or is there another computing unit that we're not yet familiar with that could play a part in actually serving a lot of the AI?
Yeah, that's a great question, and I think it's also clear that AI is going to get more and more efficient as you innovate, right? So today's largest model capabilities will be subsumed by tomorrow's smaller model capabilities, and that trend is continuing on. And so as models shrink, the energy requirements come down, and you get efficiencies that will make AI much more pervasive. So we believe in that. We see that as a trend. And then, coming back to your question on like how do we see architectures, we at AMD actually subscribe to this philosophy that AMD AI is going to be everywhere, right? It's going to be there in the highest performance GPUs. It's going to be there in CPUs with specific instructions that accelerate AI. We were also the first to drive a dedicated AI accelerator onto an x86 platform. And those are tiny, tiny accelerators, extremely high energy efficiencies. And we have embedded platforms where we have, from cars to communication networks to NBA games, AI is getting infused. So we see a world where AI is pervasively infused everywhere. However, I would say that for the highest performance capabilities and where the largest amount of innovation needs to happen and is happening in the near future, you do require the general purpose capabilities of a GPU. That remains the primary workhorse. And people forget, right, that GPU is a graphics processing engine, right, at its heart. But today's compute GPUs are hardly graphics engines. They are actually general purpose compute engines that are incredibly valuable for doing intensely parallel neural network processing. With the rate of change and algorithmic innovation there is, you need the general purpose capability of a GPU. And at least in the near term, and call it the next 3 to 5 years, that is expected to be the workhorse.
Speaking of the next 3 to 5 years, let's look forward a little. So obviously you recently released ROCm 6.4. Congrats on the release.
Thank you.
What does it mean for today, and what does it tell us about where AMD is going?
Yeah, we've been on this big push to ensure that we deliver the best-in-class experience for developers through our tooling and our software. And our journey has been also to partner with the open community. So we're continuing on that. If you looked at where we have come from, we've come a long ways in the last 12 to 18 months, right? When we first sort of announced our AI products in the GPU space, and you were able to pull down ROCm that runs on these and said, hey, what might my experience be? I don't think we could have said that, hey, any model you run, your experience would be this, right? Because we didn't necessarily have all of that. But in the last 12 months, based on the work we have done with partners like Hugging Face or PyTorch, I can say extremely confidently that any model you'll pretty much run out of the box. So that is a reasonable statement we can make, because we've now tested, right, that there are 60,000 backbones, for example, that we test nightly with Hugging Face, that guarantees that 1 million models that are hosted there are going to be able to run. So we've come a long ways, right, to be able to take workloads that are just any workloads and running on our platform. What is our journey now moving forward is to ensure that the latest innovation with respect to performance, with respect to the new algorithms, is coming as fast as possible onto the AMD platforms. So ROCm 6.4, packs in a number of features, at multiple levels, whether it's libraries, compute, communication, or basic things like driver support for new products that we're putting out. So it packs in a whole set of capabilities. And then as we look forward, we always support our next generation hardware. So we've announced that our next set of products, MI355, which will be coming at the middle of this year, we'll have software support for that. It's again introducing new capabilities like 4-bit precision, so new algorithms, new libraries to support those. Increased focus on communication as we are expanding our footprint of use cases that require distributed inference and training support. So lots of exciting things to look forward to with ROCm.
So one of the reasons I'm in India is to meet with a bunch of clients here. And the question I've always gotten is, how do we stay ahead?
Mm-hmm.
And now the question is, how, the people are asking is, how do we just not fall behind, right? This is the question that enterprises are asking as they start to feel like the startup ecosystem, the folks that are adopting your infrastructure, your platforms, are moving much faster than theirs. What is your advice to businesses for future-proofing their tech stack for large scale AI integration? But let's just call it business evolution. Let's just call it what it is. I mean, it's the new normal.
Yeah, I grew up in India, so I can definitely relate to some of the thinking and thought processes there, right? So I'll give you maybe an interesting way to think about it. When I grew up, this was in the late 70s, mid 80s, right? It was extremely hard for India to provide telephone connections, right? This was landlines that were getting deployed. And so it was quite the joy when we first got our landline at home. I remember that, right? And it was a long wait. You had to wait, you had to apply, and it was all by allocations. And even, we were amongst the more fortunate to be able to get that. The vast majority of India never had landlines, right? But then what happened was mobile came along, and you can see every Indian has a mobile phone now, right? And what I think when I think of that, what happens is it's a generational leapfrog, right? You basically skip a bunch of technology in the middle and just leapfrog to what is the latest and greatest. I think that kind of an opportunity exists with AI. You don't need to tread all the path that has been tread. You can catch up, right? And in a geeky way, I can think, right, like, okay, you don't need to understand, applications that were traditionally solved by RNNs and CNNs when the best transformer architecture basically solves it. Or you can just pick it up, right? You can download the latest model, which is a transformative model, and chances are it works fine. So that sort of opportunity exists. I would also say it's a very unique time because a lot of people grew up in the AI programming it very close to metal, right? Writing, painful assembly and, detailed, C kind of code. But then the way programming environments and abstractions are being evolved right now is it's giving rise to higher levels of abstraction. And, you can program in Python, or you can program in block level programming abstractions that are way, way more easier and more efficient. And you're able to get to innovation much faster. And then from a pure business point of view, I think a lot of focus in the past few years has been, on creating the models and creating the innovation, creating the intelligence. And we are now starting to see the shift towards leveraging that innovation to serve and to build applications.
I spend a lot of time now trying to tell people that we are approaching a future of unmetered intelligence. This idea that intelligence will be free, and we need to stop thinking about differentiating collectively and individually on the basis of how smart we are. And I have to make some pretty bold assumptions about the speed, which I think are somewhat safe, but are still assumptions about the speed at which the inference will improve on both a performance basis, but also on a cost basis. What are the trends that you see? First of all, what do you think? And what are the trends that you see informing our path to unmetered intelligence?
So I am with you in the way you see it, right? We are on a extremely steep slope of driving down the cost of inference and making intelligence more pervasively available. I was talking to one of the foremost AI researchers in the world. They are creating the next set of AI innovation that they believe will be in the next 10 to 20 years. Amazing amount of new drugs will be created, right? I was talking to another professor friend of mine at Stanford. He said LLMs are amazing for the long tail problem, right? So it's just like there are many disciplines where the long tail problem is extremely hard to solve. And if you can clean that up, you can transform factories, you can transform automation, you can transform so many industries. So I think as we drive down the costs and as we make intelligence more pervasively available from the cloud to the edge to the endpoint, I think the opportunities to create disruptive products and innovation just is on a different curve that keeps rising.
Yeah, I agree. My father's an oncological researcher, and I'm always reminded that there are only 10,000 of oncological researchers in the world. Right? It's a very big problem, but it turns out when we're born, only a certain number of those people qualify for the job, and so we're all sort of sitting around saying, "Hey, when are you all going to figure this out?"
That's
And
right.
we suddenly have a chance now to say, "Hey, well, actually, we can supercharge you, right? What if it's 10,000 researchers behaving like it's a million?"
That's right.
Um,
And if you look at just to catch that thread, if you look at a lot of the new drugs that are being created, right, it's the discovery of the magical sequence of proteins or DNA sequences, right? And can you imagine if all of this data is being processed by the right model it's almost, you can see it. It's going to happen, right? A new class of drugs is going to emerge.
In closing, what can you leave us with?
I haven't felt this excited in my entire career, that we are living in an amazing time. I feel that way both from a pure technology, intellectual fulfillment perspective, but also the possibilities to improve, human life at large, right? That come with it. It's just such an exciting time, and I find it like the privilege of life to be able to be here at this time, do the work, and make an impact.
I second that. I remind myself and anyone who will listen to me constantly that today is the best day ever to be born,
Yeah,
and tomorrow probably will be too. And that trend shows no signs of slowing. And despite all of the things that we perceive as being wrong with the world, irrevocably in some cases. In
yeah,
fact, they aren't. And in fact, our modern history has proven that the world does get better thanks in large part to technology, thanks in large part to the work that you all are doing to help good actors do more good at a faster rate. And it certainly seems to suggest that we are on the precipice of some incredible step functional improvements in the human experience. And if you and I and our optimism are right, then it could it could be pretty magical. Anything else you want to leave us with?
yeah. And finally, for our developer friends, come check us out at our Advancing AI event in June, and stay tuned for regular updates at the AI at AMD X handle.
Vamsi, thank you so much. We will do this again, and in the meantime, I look forward to seeing all of the work that you and your team are gonna produce.
Yeah, thank you so much, Zach. Really enjoyable conversation, and I'm looking forward to the next time.